join the 28-hour SQL Server Masterclass on the Udemy platform for only $15 instead of $89. Learn how to become a future developer or either a future DBA or performance expert on SQL Server with 150 exercises. The link to the promotion is in the video description. Okay? Want to get started on SQL Server? Then join me. Include in indexes allows you to include columns when we want to create an index. Okay? There is a syntax that allows this column to be included. At this point, it was understood that reading indexes are generally less expensive than reading data page. Okay? As long as the size of the indexes is reasonable compared to the size of the data. The bigger the indexes, the more space it takes on disk space, and the more it creates fragmentation, and so on. Okay, you have to understand this. This is very important. So it can be useful to add column to the indexes for performance purpose. This is not a good strategy because it makes the intermediate nodes of the index page too big. Okay? The larger indexes you put in, the bigger the root page will grow, and so on. So this is why the include is very interesting, because it will store the data at the level of the index sheets. Okay, so it will not impact the intermediate page nor the root node, which means that we will save space at this level. And that's the purpose of include, saving space and better performance. So we will use our database. So it's not the good one, it's structured index. Okay, let's use our usual database. Let's activate, enable the statistic, and let's do our test from this request, and we had a filter on the last name. Okay, so let's run the query. We have 4,000 logical reads, and the execution plan, say index scan. Okay, for now nothing special. So we will do we'll do a filter on the last name column. So SQL had not chosen to do a seek index. It has preferred an index scan for the moment. Okay. So we will go on the first option. We will create an index on the last name column in this column. Okay. So let's create this simple index, and let's run again the same select. It's again 4,000 logical reads, and SQL Server doesn't take the new index. So it always goes on the index scan. And we can see though that SQL say why not to create this kind of index, create non-cluster index on employee, and you can see in the syntax that we have the include. Okay, so it says if you put this kind of index, the impact could reach 86%, which is not bad. So for now, we will not work with this index. We will continue our research, and we will relaunch this request by forcing the index we are created before. Okay, we are created for it. So you can force an index with this syntax, with index and the name of the index that you have created. Okay. So let's run. And if you get a look on the logical reads, however, we went from 4,000 logical read for 40,000. Okay, so we see that forcing the index in this case does a bookmark lookup and a lot more logical reads. Okay, this is a bookmark lookup with a key lookup. So we continue our search here, and we are going to do a covering index. So in this index we will cover all the column. We will not focus on that. We have 4 columns: last name, first name, middle, initial, and phone. Okay, we cover everything. Let's go select again, and we will see that at the level of the execution plan, now we have the index seek. Okay, and now we have 2052 logical reads instead of 4,000. Okay, and to do the last test, we are going to create the index recommended by SQL Server with the include. Okay, you can see the syntax: include and the 3 columns that we have to include in this new index. So which index do you think SQL Server will choose between include or and the covering index? We will find out right away. Let's run the query, and here it opt for the covering index. It here the index that he allocated itself. Okay, so it took the covering index instead of the include. So we will play the both query at the same times, and we will first use the include index and then the covering index. So here we force the include index that we have created before, and the covering index for this query. Okay, let's run the two select, and we can see that the result is the same, 50% for the 2 queries. Okay, so there are 2 ways to make this query much faster. And in terms of logical reads, here we have 215 and for the include, okay, and 252 for the covering index. We have 2 winding less. However, it's a small table. If it was a large one, there can be some pretty big performance improvement. Finally, in this demonstration, the covering index stores all the columns of the intermediate pages at the leaf level of the index tree. So that has an impact on the volume. Also remember that if the data of this type of column is modified, it will also have an impact on the index at the level of the modification of the database. However, the include, we store the column just at the leaf page level. So what you need to know is that include does not make change to intermediate page. So that helps store more information in the page and provides more performance when traversing the tree index. Okay, so if you have the choice between a covering index and an include, you have seen that they have the same execution plan. So opt for an include, your performance will be better. Okay, so let's go to the next demonstration.